assisted by Mrs. George, and we have Mrs. Summers, who is the math teacher and still here helping out. Okay, so Miss T, are we ready, or do we need another minute? We're ready. Okay, fantastic. Okay, where are we starting? Abby and Dahlia. Excellent.
So we made a s'mores heat lamp maker.
This is our model of it. Question. Which chocolate will melt faster, dark or milk chocolate?
Hypothesis. If we use the milk chocolate, then it will melt faster.
Experiment. We are making s'mores from a pizza box and 2 of the same heat lamps.
Procedure. Get a pizza box, marshmallows, foil, chocolate, heat lamp, pencil, black paper, popsicle sticks, and of course graham crackers. Get a pizza box and cut a hole in it. Pull the flap up and put foil in the pizza box. Put graham crackers in the chocolate with marshmallow in the pizza box. Put foil on the flap. Put popsicle sticks to hold up the flap. Get the heat lamp and shine it on the pizza box. Wait a couple minutes and you have Dolly and Abby s'mores. Record of data. We have found out the dark chocolate melts faster than the milk chocolate.
Conclusion. We found out that the dark chocolate melts faster because it is more natural. In dark chocolate, there is cocoa solids, cocoa powder, and sugar. In milk chocolate, there is cocoa solids, cocoa powder, sugar, and milk.
This is where we put our s'mores, and we couldn't find the dark chocolate, so we just used the milk chocolate. And the wattage of the heat lamps is 250, and we used a ruler and popsicle sticks to hold up the pizza box.
Fantastic. Did you try using the sun, or you just did heat lamps?
We just did heat lamps.
Okay, excellent. Okay, great job. Does anybody have any questions for Dahlia and Abby? Okay, great research, girls. What would be your next experiment that you might want to test out if you were following up on this? What other questions might you have?
Maybe if the sun is hotter than the heat lamps,
Okay.
the sun would make it go faster.
Okay. Great. Okay. Fantastic. Good job. That's what we do in science. We always look for the next question to answer. Take a bow, girls. Excellent. Good job. Okay. Now where are we going? Over here to Yoni and Yitzi.
So our experiment was dissolving metal, nail, dissolved, penny, and zinc. Zinc didn't fit.
Yeah, it just is sitting there. And our research question is, which metal will dissolve the fastest? And I think that copper and zinc will dissolve the fastest.
Okay.
Background information on how the metals dissolve. The metals get replaced with hydrogen molecules. Then the hydrogen comes out of the acid in bubbles. And when we put some of them in, we definitely did see bubbles.
Okay. Nice.
My hypothesis is different than my research question. I don't know why. And then if aluminum is the weakest metal in our materials, then it will be the fastest. Our materials are a penny, a nail, phosphoric acid, glass beakers, and aluminum foil, which isn't here right now.
Okay.
See.
Okay. Yeah, keep going.
For safety, we use goggles, aprons, and coats and boots.
Excellent. Now, where did you find this phosphoric acid?
This Shaggy got it for us.
Yeah.
Okay,
We just had
excellent.
it.
Procedure is
Because,
we
keep going.
will put different types of metals in a glass and a drink cup or and we will fill each cup with the same amount of phosphoric acid, and we will record the weight over 3 weeks. And then our record of data, so February 13th is zinc. 2.76
grams.
It dissolved right away. It turned black. The acid turned black, and then it was colorless.
It stunk.
Okay.
The iron, 7.14 grams in bubbles. Pennies, all zinc dissolved. You found that pennies were mostly zinc with a copper shell on the outside, and you found that all of the zinc on the inside dissolved.
So it was very smooth.
Yes.
So what did the penny look like after the zinc dissolved?
It was smushed. I didn't feel it.
It was like this was the bottom and a small bit of the sides, and then the top was bent in like that, and there's a small hole right there.
There's nothing holding it up.
Nice.
And then copper wire, it had a light color. Then now 420. Iron nail, 7.53 grams. The nail is thin and has mushy crystals on its side. The acid is black. So penny dissolved, it completely dissolved, and the acid is still yellow acid. Oh, and before the acid was completely clear. The copper wire is still there. It's still yellow acid and smaller inside, 2.78 grams. Was your hypothesis correct or incorrect? My hypothesis was correct because the aluminum dissolved fast. Conclusion and what you would do different. The aluminum dissolved the fastest. The copper wire dissolved the last. I would have changed, if I were to do this experiment again, I would have changed the type of acid. The type of acid I would have changed it to would be bleach. The only one that crystallized was the nail. My hypothesis on page 4, which you don't see there, is that the aluminum will dissolve fastest. My hypothesis was correct. Aluminum is the weakest metal in our materials, and that is it.
No?
Good job.
Here. Dissolve.
Ooh, excellent.
And it will stink for a while.
A few seconds. But it's not that bad.
No. Oh, yeah.
And we can put aluminum in it.
Now, what are those bubbles? What kind of gas is bubbling?
Hydrogen.
Hydrogen gas.
I think I explained that.
That's right.
And yes, that is it.
I smell it.
Yeah, it's not the best smell.
Yeah.
But the
definitely.
aluminum took like 5 seconds, and then it was like blowing smoke. It was really
Yeah. Much
the
more
first time
than
we did it. The first time we did it.
Yes.
Nice.
And now I believe that.
Okay, good job, guys.
The middle's gone. Yeah. It's dissolved. Actually, it's now hydrogen. In the air. That's what this thing was.
Ew.
Okay, good job, guys.
Life lesson. Never smell hydrogen. Or carbon dioxide.
Say that again. Who are we going to? Okay.
I'm doing a glass sympathy. Does the matter here are some questions. Does the matter if there's more water in terms of the sound and pitch? If there's more water, the sound is lower, and if there's less water, the sound is higher. My background information, when you rub against the glass of the room with your finger, you make the walls of the glass vibrate. When you take your finger away from the glass continues to vibrate, producing a musical note. Less water makes a higher note because there's more space for the music to move, but if there's more water and less air, the music will be lower. My hypothesis is if there's more water, then the sound will be higher. I'm gonna quote data by how much water I use and how high the pitch gets. The procedure is you get wine glasses, then you pour with different amounts of water, and then You pour some water into one glass, then you rub against the top of the glass and see what music it presents. And then you do it with different amounts of water and how that music does differently. The observation is the most water, the pitch is the lowest and deepest. Medium water, it's the most like the action music because it isn't squeaky or deep. The least water, the pitch is the squeakiest and the highest. My hypothesis was incorrect, and my conclusion is the water works better when there was less water in the glass. The orange juice and milk barely work. The lemonade sometimes works better than water and sometimes doesn't. Next time, I'm going to use not too much, but not too little water. I'm not going to use milk or orange juice for the future.
Okay, very nice, Reno. Let's see, you can demonstrate.
I'm not good at it.
You got it. And excellent.
This
Now the
one
other
has
one.
more water. And it's different music.
Excellent. And I see you have two different glasses. One that where it's very close to the table, and one where there's a called a stem. Does that make a difference of the sound?
What?
Did you try, or maybe you would try next time, that I see you have two different glasses. I wonder what would happen if you had the same amount of water in the tall glass versus the little glass. What would be your hypothesis?
If the glasses are the same, and if they're the same amount of water, and they're close together, if you go on one glass, it comes out of the other glass because the sunlight goes through the glass.
Interesting. Okay, good findings. Excellent. Good job, Rena.
Thank you. Thank you.
Okay, who's next over here?
Our experiment was M&Ms, which one melts faster. Our experiment was which M&M color melts faster. Research question is, do some M&Ms faster than others? Hypothesis. If brown is the most chocolatey, then brown will melt the fastest. Materials, M&Ms, microwave, jar lid, weighing utensil, paper, plate, and glue. Props. Get your flat microwave plate, measure the distance to the center of the circle, and make a stop in the middle center. The jar lid over the dot and raise it. Take out the M&Ms out of the package and take out the candies that are not cracked or oddly shaped. Make 5 clusters with 3 candies each. Glue each candy to the plate. Place the plate in the microwave. Heat for 30 seconds 6 times. How are you going to record data? It's a data table. 0 seconds. Red, 0, orange, 0, green, 0, blue, 0, brown, 0. 30 seconds. Red, 1, orange, 3, green, 4, blue, 3, brown, 3. 60 seconds. Red, 3, orange, 3, green, 6, blue, 5, brown, 3. 90 seconds. Red, 4, orange, 3, green, 6, blue, 7, brown, 3. 120 seconds. Red, 5, orange, 7, green, 8, blue, 9, brown, 3. 150 seconds. Red, 5, orange, 7, green, 10, blue, 10, brown, 3. 180 seconds. Red, 6, orange, 7, green, 10, blue, 13, brown, 3.
Is your hypothesis correct or incorrect? It is incorrect.
Conclusion, and what would you do differently? The blue M&Ms melted faster than the other ones. The brown ones melted the slowest. I would have not put the glue. The glue made it harder to see the cracks in the M&Ms. We tried using Reese's Pieces and those melted faster. So maybe next time we should use Reese's Pieces and red, and we're best to eat out of all the melted M&Ms because it made like a volcano at the top.
Okay, good job. I like the Reese's Pieces part. Okay, good job. Okay. Okay, you're up, guys.
Okay. Our experiment is pH levels. Our question is, will milk be acidic?
Our hypothesis was if the milk is acidic, then the lemonade and apple juice will be basic. The materials are the litmus paper and these other liquids.
And our procedure is we are going to dip the litmus paper in the different liquids and see if they are acidic or basic.
And now we just dip the paper into the liquids.
So first we did acid
We did acid
first
because it was
because it's
dangerous.
really dangerous.
So we don't actually have it in the cup.
And this is what turned out. Here's the pH.
Yes.
pH scale is the first slide.
Yeah. This is the pH scale. So it
Good.
turned out pink.
So it's like
So it would be
like a
around
zero. It's a 0.
Yeah, it's about 1 or 0. And let's test
Now we'll test the milk.
the milk. So
So
it
it
might
take a little bit time to react.
Okay, so maybe dip the others.
Yeah.
And let's,
So we'll do apple.
Just you
Wait. Right now,
No, she would just dip it.
yeah, let it sit
you
for a
dip
minute.
it in. This is the lemonade. So, the lemonade reacted fast, and the lemonade is kind of orange, and the apple juice.
Kind of the same thing.
Yeah, it's kind of the same thing. Let's see. It's like maybe minus 5.
Also the color.
So, and the Coke was like dark, so maybe 4. And water
was
was
about the same as the milk.
yeah. I don't know why it's not reacting.
Well, the water should be pretty clear, right? It
Yeah.
should turn white.
It should
Whoa.
turn. And this was dark blue, so baking soda is really
It says
Um,
it's alkyl.
yeah.
Baking
So,
soda is going to have a
yeah.
pretty high number there.
So it's 14, which is pretty high. That's the highest.
Very
there.
basic.
And the milk is just staying the same.
So it's
The
like
milk and water are pretty basic, I guess. Maybe like
closest to here.
yeah. I guess it will just
Kind of basic.
yeah.
Okay, so any thoughts on why the water is a little bit higher? Because it says that water should be 7, right?
Yeah.
Oh well,
It might
it's
be
not pure water because it is.
from the
It's not like rainwater. It's from the water
Not
fountain.
rainwater.
It's filtered.
Okay, good theory. Good theory. Okay, good. So did you guys finish your conclusion and what you would do next time?
Yeah. Conclusion. Here.
Okay.
Our conclusion.
Is we wanted to see what would have happened if we used it on food. Like would it have worked or
Interesting.
not? And like if it was on dirty water,
Right.
sewage water,
Yeah, that
it would have had it probably like a different number on the scale.
Mhm. Okay, good. A lot of good questions for more research. Good job, guys. Yep. Okay, Debbie, tell us about your bridges.
I made two bridges. This is an arch one, and over here's a triangle one. And it says the max on the sticky notes that I put here.
Okay, good. We have
Maximum amount of pounds or books.
okay, so we have the regular bridge says max 17 books, and on the arch says max 10 books. Did you test that out?
Yes.
And you kept putting books until it collapsed?
Yeah.
Okay. And then you rebuilt it. Nice. Did it surprise you that Bridge 1 could hold more books?
Yes. Because the reason why that happened was because you might think that all the weight was up here and pushing it down, but really all the stretching pieces were down here.
Nice. Okay, good.
So the stretching pieces snapped, and then it like rolled up.
Got it. Okay. Are there other kinds of bridges that you would want to test out also?
Any that I know of.
Okay. Okay. Is that it? Anything else to add?
I got pictures.
Excellent. Let's see those pictures. Excellent. Okay, good job. Okay, good job, David. Okay, I'm just gonna have to plug in. Where did that wire go?
Did you bring one?
Yeah, I did. If you could, thank you. Okay. Okay, you're up, guys. What do you have for us?
We made an ant farm. Our research question was how many tunnels will ants make in the dark and in the light? Our background information is ants need food and water to survive like us. Ants are more active at night. Worker ants come out 15 minutes after sundown and search for food. Ants like to eat meat, greasy food, dead insects, honeydew, nectar, plants, and plant seeds. Our hypothesis was if the ants make more tunnels in the dark, then the ants will make less tunnels in the light because they're used to being underground. The materials we used are 2 ant farms, a piece of paper, 1 pencil, black ants, and dirt. Our procedure was pour dirt into both kits, put black ants in them, put one kit in a dark room, put the other kit in a light room, experiment, and record your data. We are going to record our data on a Chromebook. Our record of data, they escaped. They didn't dig any tunnels, so we couldn't record the data. We don't know if our hypothesis was correct or incorrect. Our conclusion and what would you do and what we would do differently is it wouldn't work because the ants got out.
Next time I would get worker ants. Some ants died. We ordered ants, but they died on the way to school. We got some ants in their jar, but they died.
Okay. Well, they're ants. That happens. Okay, excellent. And now you guys have all connected research.
Aiden and me are. Eras is working with Aiden, but Aiden and me are working together. That's why Eras is awesome.
Got it. Okay. So you guys want to keep going now? Perfect.
Eris and me did a soccer experiment. Our research question was, does the amount of air inside the ball, a soccer ball, affect how far it goes? Our background information was the amount of air or air pressure in a soccer ball affects how far the ball will travel when struck by the same force. The higher air pressure that is put into a soccer ball improves the ball's rebound off the foot of a player. More energy is transferred to a stiff ball in all elastic collisions. Our hypothesis was if the ball has more air in it, then it will go farther. Materials: soccer ball pump, inflation needle, pen, paper. Procedure: we filled up a soccer ball with air and let air out of another soccer ball. Then we both kicked the balls the exact same way and we both did it once. Then we wrote data on a piece of paper, then we measured it with our feet. How are you going to record your data? We are going to record our data on a piece of paper. My kick for the flat ball was 6. We measured 60 for the flat ball. For the ball with more air, we measured 62 for my kick. For Eric's flat ball, when he kicked it, was 36. For the one with air, it was 40. Our hypothesis was correct. Conclusion and what would you do differently? We would kick the ball harder. We would use the same brand of balls. We would kick the exact same way. It depends on how hard you kick. Yes, it does.
Okay, nice. Excellent. You guys got into this. Aiden, how did it come to be that you worked with 2 groups? You were part of 2 projects.
First, Eris, me, and Kiwi were all working on the ant projects, but then Eris wanted to do a soccer project, so I helped him with that, and I helped Kiwi with our science project.
Okay, good work. Good work. Excellent. And what made you guys think about an ant project?
It was the only thing I wanted to do.
Aiden wanted to do that,
Okay.
and he wouldn't do anything else, so I had to agree with him.
Well, you said you wanted to.
Okay, let's move on from there. Okay, good job, guys. Round of applause. Okay. Let's come around this way. Okay.
So we did how to make soda explode. And our research question is how much soda explodes from the can and bottle. And our background information is the soda explodes because of the bubbles made from carbon dioxide. The bubbles shake around, forming new bubbles, which creates more fizz, and then it explodes a lot. Hypothesis: if we shake it for a minute, then it will explode the most because when you shake it, a lot will explode. Materials: soda can, soda bottle, aluminum pans, aprons, gloves, measuring cup, and towels. Procedure: shake a soda can and bottle for 10 seconds. Shake a soda can and bottle for 20 seconds.
Shake a soda cannon bottle for 30 seconds. Shake a soda cannon bottle for 40 seconds. Shake a soda cannon bottle for 50 seconds, and then shake a soda cannon bottle for 60 seconds. We are going. How are you going to record the data? We are going to graph it. Record of data. Seconds. So this is the graph, and this is like for 10 seconds.
Yeah.
It 150 like grams came out,
Okay.
and then for 20 seconds 100 came out, and for 30 seconds 155 came out, and then for 40 seconds 140 came out, and then 50 seconds 190 came out, and then 60 seconds 195, and then this is the cans. The cans were less than the soda. For 10 seconds it was 0. For 20 seconds it was 110. For 30 seconds it was 100. For 40 it was 111. For 50 it was 110. For 60 it was 110. And
Okay, nice
now,
chart.
what was your hypothesis? Correct or incorrect? Your hypothesis was correct, only with the soda and not with the cans. And 10.
You mean with the bottle? With the bottle, but not the
Yeah,
cans?
yeah.
Okay.
Conclusion, and what would you do differently? Conclusion. The soda exploded better than the cans. The cans are meant. What we would do differently is we would put the cans and the cans and soda in the microwave, and then we would keep on our gloves and put on our aprons. Then special thanks. Special thanks to Rena Siegel, Miss T, Mrs. Summers, Mrs. George, and Dr. Wise. And then we have a
You have a
sample.
demonstration. Excellent.
So Rena's gonna set the timer on her Chromebook. Okay, so no, 3, 2, 1. Start. 9, 8, 7, 6, 5, 4, 3, 2, 1. That was 20 seconds, and that was a lot. Okay. Hope you enjoyed our science project. That was 180. Yeah, it was 180. So,
Okay.
and
Okay, great. And in your what you would do next, you said something about a microwave?
yes, we put the soda in cans in the microwave for a minute, and then we would see what happens and see if it would explode more or less.
Wow. We wouldn't put a can in a microwave, but because we wouldn't put metal.
Yeah.
But the bottle would be very interesting to see, of course, with adult supervision, because it could explode before you're ready. So, okay. Okay, good work, scientists.
Thank you.
Okay. Okay. Hold on. I was plugged in because I was charging, but no, we'll be okay.
Okay.
Where I should stand here? Okay.
Okay. How music affects the growth of plants by Miriam and Sophie. Research question. Does music affect the growth of plants? Background information. Previous studies have shown that playing soft music helps plants grow rather than harsh music. I think that when plants grow in the wild, it's more used to a soft, gentle breeze rather than harsh, which is why I think it prefers softer music. Hypothesis. If the music helps the plant grow, then the plant will grow faster or slower.
Materials were 3 bean plants, pots, water obviously, 2 devices that play music, and mouse. Our procedure was 1, gather materials, 2, using the masking tape label, a pot rock music, and on the other, put classical music, and on the last one, put no music. 3, put the bean plants in the pots. 4, give the one that says rock music some rock music on one device, and the one that's classical music on the other device. And give the one that says no music. 5, give all the plants a different sunny place so they don't hear the other device's music.
Okay, good.
And
Makes sense.
6, water the plants every day. Obviously, otherwise they won't flourish. And then, how are we going to record the data? I'm going to use Google Sheets. In Google Sheets, you can put how many inches it is. The next day, you can see how much you put last time, and then see how much it would have grown. It actually is very simple. You might want to put the date too. I would put the date if I were you.
Record of data. Rock, 12 inches. No music, 9 inches. And classical music, 7 inches.
Was our hypothesis correct or incorrect? It was correct. And then the conclusion was, I conclude that the plants like rock music. The plant is fine with no music, and the plant doesn't really like classical music. I think plants like the rock music because it's entertaining, so it starts to grow. The classical music is just plain old boring. The no music plant was just watching people, so maybe entertained by that. Not really sure about that. I mean, it could be since it was in the plant, it's in the pot longer, but not 100% sure. And what would I do differently? I would play better music, especially the classical. The classical was so short compared to the other ones, obviously because it was boring. But also not put it in my laboratory. I did not ask it, so don't blame me.
Okay. Conclusion and what would you do differently? I conclude that different music helps more than others, and different plants get different results. I think that if we did multiple experiments and had more time, then we would have different results. And I also think that if we had done the same music every day, and if we had, we would have heard the most complaints ever. It would have helped.
Okay, and then
Nice.
we have how much it grew.
Yeah.
So for the rock music on April 28th, the rock music over here,
Right.
it was 6.5 inches. And then the classical music, which is here, was 2 inches. And then the one with no music was 8 inches and 1/4. And then on April 29th, the rock music was 2 lines below the 8 inches. And then the classical was 3 inches, and the no music was 9 inches. And then the rock music on April 30th, 10 inches, 6 inches, and I think it's 8.5 inches. No, 10.5. Yeah, okay.
Nice.
And then May 3rd, rock music was 12 inches, classical music was 7, and this one was 11.
Okay. Good work. I do have one question. Did you look at the volume? Like, what would happen if you played rock music? What do you think would happen? Played rock music like really, really loud versus just normal volume. Do you think that would make it grow more or less?
Well, the rock music was right next to the plant, and it was almost as loud as it could go.
So you did try it really loud.
I want to hear the music too.
Yeah, but we didn't do the same music every day because the original song that we did,
Was
Like-
really annoying.
yes, it was very annoying because it was just the same words over and over and over again.
And we had so many things.
Yeah,
Okay.
so we had to change it.
Okay, that would be interesting to see different songs and maybe how many beats per minute, things like that. That could be really interesting research. Okay, great job, girls. I'd love to see more research like that. Okay, big round of applause for the fourth grade. We'll give everybody a chance. They could wave, just say thank you for coming to everybody. Okay, and of course, thank you to Ms. Troggett and to Mrs. George. Okay, thank you everybody for coming. We hope you enjoyed and have a great rest of the day. Thank you.
Bye.